Okay, we continue to solve examples for the method of variation of parameters. Okay, we will now solve this differential equations. We will find the general solution of y double prime plus y is equal to secant x using the method of variation of parameters. So if you recall that in step 1 we always find the complementary solution. So complementary solution. So what is it? It is the solution of the homogeneous part. So corresponding homogeneous part. Okay, we will find this then homogeneous part. So what is it? Y double prime plus y is equal to 0. Okay, what is the characteristic equation? So the characteristic equation in this case is lambda square plus 1 is equal to 0. So we have lambda square is equal to minus 1. So we have complex roots, right? So this is plus minus I. If you recall that when we have complex roots, so how we write y complementary, it was c1 e to the power alpha x, sorry, cosine beta x plus c2 e to the power alpha x sine beta x. In our case, so it is plus minus e. So alpha is equal to 0, beta is equal to 1 in our case. So then what is y complementary? Since alpha is equal to 0, e to the power alpha x is equal to e to the power 0, which is 1. So we have c1 cosine x plus c2 sine x. So this is our complementary solution. Then in step 2, we assume that y particular is of this form, u times cosine x plus v times sine x. And in step 3, we also assume, for simplicity, we always assume u prime y1 plus v prime y2 is equal to 0. So in our case, it is u prime cosine x plus v prime sine x is equal to 0. So this is our y1, c1 y1 plus c2 y2. Okay, we will assume these and we substitute, and to find u and v, we will substitute first derivative and second derivative y double prime in the equation, in the given equation. So what was the given equation? Okay, y double prime plus y is equal to secant x is our equation. So let's find the derivatives. U cosine x plus v sine x. What is the first derivative? Don't forget to use the product rule, right? So it is u prime cosine x plus u, the derivative of cosine x, minus sine x plus v prime sine x plus v, the derivative of sine is cosine x. So okay, I'm using this product rule. U prime v is equal to u prime v plus uv prime. And we assume that, so this is equal to 0. So because we assume u prime cosine x plus v prime sine x is equal to 0 from assumption. From our assumptions, then what is yp prime? It is minus u sine x plus v cosine x. But we need the second derivative, so it is minus u prime sine x minus u times derivative of cosine u is cosine x plus v times minus sine x. Oh, sorry. Okay, I will take first the derivative of v, so v prime cosine x minus v sine x. Okay, great. So let's substitute in the equation. So we have u prime sine x minus u cosine x plus v prime cosine x minus v sine x. So this is yp double prime plus yp, so u cosine x plus v sine x, and this is equal to secant x. Okay, let's see if anything cancels. So we cancel these ones, minus u plus v minus v. So we are left with u prime sine x is equal to, okay, let me write it here. I will copy it. U prime sine x minus v plus v prime cosine x is equal to secant x. Okay, I will copy this. Okay, I have this simplified equation. Now I should have two equations, and the other one is our assumption. So if you remember, we assume that u prime cosine x plus v prime sine x is equal to 0. So this was our assumption. We can find u and v. Okay, what we can do is we will just multiply the first equation with cosine x and the second equation with sine x, and we will add these two equations, because then the first term will cancel, right? So when we multiply with cosine x, the first one, so cosine x, the first one, then we have minus u prime sine x times cosine x. And what about the second one? So we will have plus u prime cosine x sine x. So when we add, these two will cancel. And what we are left with is v prime cosine square x plus v prime sine square x is equal to secant x times cosine x, right? Because don't forget to multiply cosine x with secant x also. So we should multiply all of them. So, and we know secant x is 1 over. So what is secant of x? So it is, I think, 1 over cosine x, right? So we are lucky, because this multiplication will be 1. So when we take v prime parentheses, we have cosine square x plus sine square x, and this is equal to 1 over cosine x times cosine x. So these are 1. We are very lucky. So we find v prime is equal to 1. And when we take the integral, then v is equal to x plus c. But as I said, we will always choose c is equal to 0 because we want the simplest function. You can choose whatever c you want, but we don't want any arbitrary constant, so you need to choose one c. We want the simplest function. So we have v is equal to x. So let's using always, we will use second one to find u prime cosine x plus v prime sine x is equal to 0, and we know v prime is equal to 1. So what is u prime cosine x is equal to minus sine x. So u prime is equal to minus sine x over cosine x. Okay, now we will integrate to find u. Okay, if we let cosine x to be, let's say, some function t, then we have, so we will use it by substitution. Sine x dx is equal to dt, so u prime is equal to dt over t, right? and which is equal to ln t plus c. Again, choose c to be 0. Choose c is equal to 0. So we have u is equal to ln t. But what was t? So t was cosine x. So we find v to be x, u to be ln cosine x. Then what is our y particular? Y particular was u times y1 plus v times y2. So u times cosine x, right? U times. Okay. So this was our y particular, u times cosine x, v times sine x. So it is u times ln cosine x plus x sine x. And what is the general solution? General solution was y complementary plus y particular, and we find the y complementary is c1 cosine x plus c2 sine x and plus y particular. X sine x. So this is the solution of the so this is our general solution of y double prime plus y is equal to secant x.